Hi dear students, welcome to our channel Exam Side Mathematics by Pani. In this video, we are discussing about application of derivatives. In that, rate measure or rate of change, we are going to discuss now in the exercise 6.1. In the exercise 6.1, this is the first exercise in application of derivatives. Exercise 6.1, dear students. In this video, from question number 1 to question number 10, we are discussing now. Okay, let us have a discussion in the question here. Find the rate of change of the area of the circle with respect to its radius. Rate of change of area. Area denoted by what? A rate of change of area with respect to radius. That means d by dr of area, dA by dr, we can calculate. That means area of the circle differentiate with respect to r. Rate of change means dA by dt. With respect to time, we should do that. Okay. Now, with respect to radius, they mentioned, so dA by dr. This we are going to calculate for this question. So, what is the area of the circle? Area of the circle A is equal to area of the circle. A is equal to pi r square. Next, what they are asking to find? dA by dr, no? So, differentiate with respect to r. Differentiate with respect to r. So, dA by dr is equal to pi into d by dr of r square. D by dx of x square is what? To x. Similarly, d by dr of r square to r. So, dA by dr is equal to 2 pi r. We got it. Here two questions they asked. One is, when the radius is at 3 centimeters, what is the rate of change with respect to r? Case 1. When r is equal to 3 centimeters, dA by dr, like this you have to write, dear students, dA by dr when r is equal to 3. So wherever r is there in this place, you have to replace with that. So which is equal to 6 pi. Area, it denotes with centimeter square. R means centimeter, like this. Okay. Next, even if you want to calculate one of the centimeters, you can calculate. Next, when radius r is equal to 4 centimeter, dA by dr. So when r is equal to 4, so 2 pi into 4, which is equal to 8 pi centimeter square per centimeter. So this is what our answer is, students. I hope you understand. We'll move to another question. Okay. Yeah. So the volume of a cube is increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing when the length of an edge is 12 centimeter? See here, volume of the cube and surface area of the cube when the edge is at x centimeters. So volume of a cube V is equal to x cube, where x is the edge of a cube. So the volume of a cube is increasing at the rate of, and given dV by dt is equal to 8 centimeter cube per second, dear students. Here also differentiate with respect to t. So v derivative with respect to t is what? dV by dt. X cube derivative with respect to t. So 3x square Again, x square derivative is, sorry, 3x square, x derivative we need to do that. Dx by dt. Okay? In place of dv by dt, you replace with 8. So it will brings 8 equal to 3x square into dx by dt. So the 3x square also bring this side. 8 by 3x square is equal to dx by dt. So put it in the box and keep it as equation number 1. Okay, I hope you understand the students. Next, surface area of a cube. It is denoted by S, dear students. S is equal to 6x square, where x is edge of a cube. X is equal to edge of a cube. Differentiate with respect to T. What they are asking to find? How fast is the surface area increasing? What is ds by dt when x is 12 centimeter? So ds by dt I am going to write here, students. ds by dt is equal to 6 constant. X square derivative is 2x. Again x derivative is dx by dt. So 6 into 2 is 12x into, in place of dx by dt, you replace with 8 by 3x square. Okay. So one of the x cancel, 3 ones, 3 fours. That is equal to 32 divided by x. But they are asking to find ds by dt at what centimeter? At the edge of x is equal to. When x is equal to 12 centimeter, x is equal to 12 centimeter, ds by dt is equal to the rate of change of surface area of the cube when x is equal to 12 centimeter is 32 divided by 12. So by 8 table, 4 table, 4 8s are 4 3s are. So S means it is in centimeters square per second. So therefore ds by dt, the rate of change of surface area of a cube is ds by dt when x is equal to 12 is 8 by 3 centimeters square per second. Okay, dear students, I hope you understand. We'll move to another set of questions. Those who are watching, please share to your friends and relatives. Those who are studying 12th class CBSE, for them you can share that. This is my sincere request. Dear friends, dear well-wishers, the next question number 3. The radius of a circle, is increasing. Radius of a circle is increasing uniformly at the rate of at the rate of 3 centimeter per second, find the rate at which find the rate at which the area of the circle is increasing when the radius is 10 centimeter. This is question number 3. Next, question number 4. An edge of a variable cube is increasing at the rate of 3 centimeter per second. How fast is the volume increasing? How fast is the volume increasing? Volume of the cube increasing when the edge is 10 centimeter long. To solve these type of problems, dear students, first we need to understand the given question thoroughly. If you read the question thoroughly twice or thrice, the problem solving is very easy, dear students. See, come to the question number 3. The radius of a circle is increasing uniformly at the rate of 3 centimeter per second. That means the radius is the increasing in the radius. So the increasing in the radius is given by dr by dt. Here the radius of a circle given increasing in radius of a circle. A radius of a circle is 3 centimeter per second. That is dr by dt, that is equal to 3 centimeter per second. The rate of change of radius, that means the increasing in the radius of the circle means. Next, find the rate at which the area of the circle is increasing. What they are asking to find? They are asking to find dA by dt, question mark. At what radius? When r is equal to 10 centimeter. This is the question. dA by dt when r is equal to 10 centimeters. So, area of the circle. So, area of the circle A is equal to what? Pi r square. Okay, dear students. Next, differentiate with respect to t. So, dA by dt is equal to pi is constant. So, the rest of the term we are going to differentiate with respect to t. So, r square derivative is 2r. Again, r derivative with respect to t is dr by dt. You know the value of dr by dt now from here. You can substitute here. So, 2 pi into r, in place of dr by dt, you replace with 3. Since dr by dt value is given as 3 centimeter per second. Okay, dear students. So, it will be 6 pi r This is what? dA by dt, the rate of change of area of the circle. A rate of change of area of the circle when R is at what units? 10 centimeters. When radius R is equal to 10 centimeters, dA by dt is equal to, so 6 pi into R value 10, that is equal to 60 pi, area means centimeter square per seconds. Okay, dear students, I hope you understand. This is the rate of change of area when R is 10 centimeters. Now come to the question number 4. An edge of a variable cube is increasing at the rate of 3 centimeter per second. So edge, let us consider, let x be the edge of a cube, edge of a cube, then the increase in edge of variable cube, of a variable cube, here also variable cube, is 3 centimeter per second. That means increase an edge of a variable cube is, that means dx by, that is dx by dt is equal to 3 centimeter per second. What they are asking to find? How fast the volume of the cube is increasing. That means dV by dt they are asking. dV by dt they are asking to find when x is equal to 10 centimeters. This is the question, dear students. Okay. So volume of the cube, variable cube. This is volume of the variable cube. Volume of variable cube. So differentiate with respect to t. dV by dt is equal to x cube derivative is 3x square. Again x derivative is dx by dt. So dx by dt value we got it now. So since the value of dx by dt is equal to 3 centimeter per second, so 3x square into 3, that is equal to 9x square. So dV by dt. But dV by dt at what value they are asking? 10. So now, when x is equal to 10 centimeter, the rate of change of volume of the cube, when x is equal to 10, wherever x is there, replace with that. So 9x square means 9 into 10 square, that is equal to 900. Volume means centimeter cube per second. Okay, dear students, I hope you understand. We'll move on to another set of questions. Next question number 5. A stone is dropped. A stone is dropped into a quiet light and waves move circles at the speed of 5 centimeter per second at the instant when the radius of the circle is when the radius of the circle is circular wave is 8 centimeters. How fast is the enclosed area? How fast is the enclosed area? Increasing. So this is the question. Next question number 6. The radius of a circle is increasing at the rate of 0.7 centimeter per second. What is the rate of its circumference? So, question number 7. A little bit big question, but we'll do it. The length x of a rectangle, is decreasing at the rate of 5 centimeter per minute, and the width y is increasing. At the rate of 4 centimeter per minute. When x is equal to 8 centimeter and y is equal to 6 centimeter, find the rate of change of first one, the perimeter. So question number B, the area of the rectangle. Okay, dear students, we'll move to solve this question. These are good questions, Nisha. A stone is dropped into a quiet lake. That means this is the lake. A stone is dropped into that. This is the stone. Whenever you are dropping the stone into the quiet lake, the water ripples are coming like this, dear students. This is the way it comes. Am I right? Are you observing the figure? This is what happening in the quiet lake. When you drop the stone into the quiet lake, the water ripples. The water ripples which are looking like circular waves, which are called circular waves. In that, moves circular at the speed of 5 centimeter. That means from here to here, which are called indirectly radius. No? The rate of change of radius is given indirectly. Given the rate of change of radius. Sir, how can you know that this is radius? The speed of waves, circular waves means it is depend on radius only. Clearly we are observing here. That is called what? Radius. The speed of the radius means what? It is the rate of change of radius. dr by dt is given as 5 centimeter per second. Okay. At the instant when the radius of the circular wave is 8 centimeter, when the circular radius, when it reaches to radius is 8 centimeter, at the particular time, what is the how fast is the enclosed area is increasing? How it will be increasing? So area of circular wave, A is equal to pi r square. Okay. So differentiate with respect to t. dA by dt is equal to pi into r square, derivative is 2r, again r derivative is dr by dt. You know it is given that dr by dt as pi, no? So 2 pi r into 5 which is equal to 10 pi r dA by dt. The rate of how fast is the enclosed area is increasing when the circular wave at the instant radius is 8. When radius r is equal to 8, dA by dt, r is equal to 8 centimeters, 10 pi into 8, which is equal to 80 pi centimeters square per second. This is our required answer, dear students. When radius is at 8 centimeter, the rate of increase in the area of the circular wave is 80 pi centimeters square per second. Now come to the question number 6. The radius of a circle is increasing at the rate of 0.7. Directly it is given like this. Given that increasing in the radius, increasing in radius equal to dr by dt is equal to 0.7 centimeter per second. dr by dt, increasing in radius means dr by dt. Rate of change of radius is also the same meaning. Okay. Next here, what is the rate of its circumference? That means circumference denoted by c. Circumference of the circle is c equal to 2 pi r. They are asking to find dc by dt. So circumference of the circle. C is equal to 2 pi r. So what they are asking to find? They are asking to find dc by dt. So differentiate with respect to t, you will get dc by dt. 2 pi is constant, r with respect to t differentiate means dr by dt will come. You know the value of dr by dt is given as 0.7 now. Substitute in this. So you will get 2 pi into 0.7 centimeter per second. Therefore, the rate of change of circumference is equal to 1.45 centimeter per second. The rate of change of circumference, the rate of change of circumference dc by dt equal to 1.45 centimeter per second. Now come to the question number 7. The length of the rectangle is decreasing at the rate of 5 centimeters. So for the rectangle, we need to consider breadth and length. No? So let us consider length is x. Length is equal to x, breadth. Or here according to the question, width it is given. According to that only we can go. Width is equal to y. Length is x, width is y. So the decreasing, the length of rectangle is decreasing. Length of rectangle is decreasing is 5 centimeter per second. That is dx by dt is equal to, whenever it is decreasing, you consider before that minus 5 centimeter per second. Okay, dear students. Next, width y is increasing. So width of rectangle is increasing is 4 centimeter per minute. Sorry, not second here also minute, dear students. That is dy by dt is equal to 4 centimeter per minute. Okay. After writing of these steps, find the rate of change of perimeter. What is the perimeter of the rectangle? 2 into L plus B. L is the length, B is the width or breadth. So in place of L and B, what values we have taken? X and Y we have taken. So the perimeter, the first question, the perimeter of rectangle, P is equal to 2 into X plus Y. Okay. After that, what we have to do? The rate of change of perimeter. So differentiate with respect to P. So dP by dt. Two constant keep aside. X derivative with respect to t is dx by dt. Y derivative with respect to is dy by dt. Okay. Later on solving these two. So dx by dt value is minus 5 plus dy by dt is 4. So which is equal to minus 1 into 2. So the rate of change of perimeter of the rectangle is minus 1 into 2 is minus 2. Perimeter is centimeter per minute. Okay, dear students. So therefore, the rate of change of perimeter of rectangle is dP by dt. Now come to the question number B in this. The area of rectangle. A is equal to L into B, that means X into Y. No? Now differentiate with respect to T. Why we have to differentiate with respect to T? To get the rate of change of area, dA by dt. So dA by dt is equal to, here we are going to apply UV formula, product rule of differentiation. X into Y derivative is dy by dt plus Y into dx by dt. So in place of x, since the values of x and y is given, x is equal to 8 centimeters, y is equal to 6 centimeters, dear students. So 8 into dy by dt is given as 4, plus y value is 6 into dx by dt is given as minus 5. So 32 minus 30, that is equal to 2. Area means dA by dt. Area means centimeters square per minute. Therefore, the rate of change of the rate of change of area of rectangle is, okay, dear students, this is the way we can do. We'll move to another set of questions. Okay. Yes, students, more 3 questions, 8, 9 and 10. A balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeter cube per second. Pumping of gas in 900 cubic centimeter per second. Find the rate at which the radius of the balloon increases when radius is 15 centimeter. The same type of question, it is enough for this. Question is big one, but answer is small. A balloon which always remains spherical on inflation has a variable radius. Find the rate at which find the rate at which the radius of the balloon find the rate at which the volume is increasing. Find the rate at which the volume is increasing. With the radius when the latter is is 10 centimeter. That is question number 10. So in this session, this is the 10th question, is the last one. A ladder 5 centimeter, 5 meter long is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. How fast is the height on the wall? How fast is the height of the wall simply? What was the height on the wall? Height on the wall decreasing when the foot of the ladder is 4 meter is 4 meter away from the wall. Away from the wall. A balloon which always remains spherical on inflation is being inflated by pumping of gas 900 centimeter cube per second means given that dV by dt, the rate of change of increasing in volume of the spherical balloon is 900 centimeter cube per second. Find the rate at which the radius of the balloon increases. So, volume of spherical balloon is V is equal to 4 by 3 pi r square, pi r cube. Okay. Differentiate with respect to t. So, dV by dt is equal to 4 by 3 pi is constant, r cube derivative is 3r square. Again r derivative is dr by dt. So 3 get cancelled. dV by dt value is given as 900 is equal to 4 pi r square into dr by dt. So they are asking to find the radius of balloon increases. So dr by dt they are asking. So you can make subject to dr by dt. The rest of the things we can bring this side. So 900 by 4 pi r square is equal to dr by dt. But dr by dt at what radius they are asking? When radius is 15 centimeters, dr by dt is equal to. So wherever 15 is there, replace with that 900 by 4 pi into 15 square. So 900 by 15 square is 225. 225 into 4 is 900. 900 into pi. So 1 by pi. Radius means centimeter. T means second. So dr by dt when r is 15 centimeters is 1 by pi centimeter per second. This is the radius of the balloon is increasing when the radius is at 15 centimeter. I hope you understand this, students. We will move to another question here. A balloon which always remains spherical on inflation has a variable radius. Find the rate at which the volume is increasing when the radius is, the later is 10 centimeter. Same case. But dr by dt, we need to calculate. Here I think something is missing here values. Once I will check it. Yeah, here nothing is missing. It is everything is good only. Here you need to understand after writing the formula of volume of the spherical balloon, find the rate at which the volume is increasing with respect to radius. That means dV by not dt. dV by dr we can do that. See volume of spherical balloon is V is equal to 4 by 3 pi r cube. So what we have to do to get the answer is differentiate with respect to r, not t. Why? Because increasing with the radius. So differentiate with respect to r. So dv by dr is equal to, with respect to r we are doing 4 pi by 3 is constant. R cube derivative is 3r square. That's all. 3 get cancelled. dv by dr at what radius they are asking? 10 centimeters. When radius is 10 centimeters, so dv by dr equal to 4 pi into 10 square. That is equal to 4 pi into 100, which is equal to 400 pi. That is also volume means centimeter cube per centimeter radius. Okay, dear students, we'll move to another question. This is only they are asking. A ladder 5 centimeter long is leaning against a wall. See, this is the ladder, this is the wall, this is the ladder. How much is 5 meter long? This is the ladder. Okay, this is the foot of the ladder is this one. Foot of the always against the wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter. From here to here, if I take x units, this is the base or bottom of the ladder. So from here to here it is x. But given the distance here up, observe carefully, dear students. The ladder is pulled along the ground away from the wall. This is the wall, no, this is the wall. From the wall, it is pulled away from the wall. How much it is distance I am taking x. So the rate of change of x is given. So dx by dt is given as 2 centimeter per second. Okay. Next, I am taking this distance from base foot of the wall to ladder is y. How fast is the height of the wall? Height of the wall is equal to y I am taking. Is decreasing when the foot of the ladder is 4 meter. When the foot of the ladder is 4 meter. Foot of the ladder means from here to here it is 4. When x is equal to 4, so they are asking to find dy by dt, question mark. Okay, dear students, first this is the ladder position. From foot of the wall to foot of the ladder is x units. The rate of change of x is given. X, when x is equal to 4, they are asking to find the rate of change of y. That means height of the wall. So from the figure, it is a rectangle triangle. From figure, x square plus y square is equal to 25. Okay. Differentiate with respect to t. So 2x into dx by dt plus 2y into dy by dt is equal to constant derivative is 0. So I want dy by dt, no. So 2y into dy by dt is equal to minus 2x into dx by dt. So both sides 2 get cancelled. Dy by dt is equal to minus x by y into dx by dt. Dx by dt value is given as 2, substitute in this. Dx by dt is equal to, dy by dt minus x by y into 2. Before that, we need to conclude x and y values now. So how to conclude x and y values is, when x is equal to 4, x square plus y square is equal to 25. So 16 plus y square is equal to 25. Y square is equal to 9, y is equal to 3. So y is equal to 3. When y is equal to 3, x is equal to 4 now already is given. So when x is equal to 3, y obviously has 3, dy by dt is equal to minus x value, what is 4 now? It is given as 4. 4 by y value 3 into 2. That is equal to minus 8 by 3. It is in height of the wall is decreasing. So dy by dt is equal to minus 8 by 3 centimeter per second. So therefore, the height of the wall y is decreasing, is decreasing is 8 by 3 centimeter per second. That is dy by dt equal to 8 by 3 centimeter per second. This is the way we can do it, students. First, especially in rate of change or rate measure, in exercise 6.1, we need to understand the question thoroughly and rate of change with respect to. If you see this question, out of 10 questions in this class, this question is little bit different. Why? Because rate of change of with respect to radius they are asking. So that is the reason. Understand the question, automatically you are able to do that. In this class 1 to 10 is over. No, the rest of the questions 11 to 18 questions we'll finish it in the next class. I think I'm expecting tomorrow. Thank you for your support. Jai Hind, exam side mathematics by Pal. Those who are watching first time, please do subscribe and share to your friends and relatives, and those who are well wishers also, you can share about this channel. In this channel, especially NCERT solutions 11th and 12th, and previous JEE mains and MSET, BITSAT, like previous questions or the type of questions I'm discussing. Once you go through the playlist of this channel, you will get it idea. Thank you all.